We are so hungry, we should eat at Hungry Jack's.
Welcome to Hungry Jack's.
Hello, we want 40 cheeseburgers and 50 Fantas and 60 French fries.
Okay, coming right up.
Oh no. We look fat.
Fatty.
Joyce, we look fat. Will George like this?
That's it. You are grounded for 1000000000000000000000000000 days. Go to your rooms now. I am telling Jane on you.
Fun facts about our solar system. Mercury is the closest planet to the Sun. It's just larger than Earth's moon. Venus has mountains on it that are higher than Earth's highest mountain, Mount Everest. It's more than 5 miles high. Earth is about 4.5 billion years old. Mars is red because it has rust on it. Jupiter has a great red spot on it that's actually a storm and has been going on for over 300 years. Saturn is a giant ball of gas. There are no solid surfaces. Neptune has rings on it that are incomplete, but they're more like arches than rings. Uranus is the coldest planet in the solar system because it's the furthest from the sun. The end.
Of all the mysteries that scientists investigate, the greatest riddle is life itself. What caused a planet like Earth to form around our sun? What sparked chemicals to burst forth into life? To help answer these questions, astronomers are studying celestial fossils from the solar system's earliest times. The planets and the sun were created 4.5 billion years ago from a whirling cloud of dust and gas. Heat from the young sun and the pressure of the solar wind swept clean nearby planets like the Earth. But farther away, the cold outer regions preserved giant gas balls like Jupiter and Saturn. Comets were to remain frozen fossils, holding secrets of the chemical makeup of the solar system's birth. Life itself is found only on Earth, but clues to its origins may be found in the distant reaches of giant planets, moons, and comets. The NASA missions to the outer solar system are named Comet Rendezvous Asteroid Flyby, or CRAF, and Cassini. CRAF and Cassini are the first missions in Mariner Mark II, a new series of spacecraft being designed to explore the outer solar system. Dr. Tobias Owen of the State University of New York.
The inner planets are small, they've been heavily bombarded, reworked from within. That early history is more or less gone. It's been very, very changed with time. But in the outer solar system, the low temperature out there has preserved the chemistry in a primitive state from the time the solar system formed.
Comets took shape billions of miles from the sun. They are likely composed of the same primitive chemicals as the ancient nebula of gas and dust that formed the sun and solar system. 1986, a fleet of international spacecraft track Halley's Comet and reveal a snowball of dust and ice, and the hint of organic compounds. In 1995, CRAF will be launched to a typical comet named Kopf. On its outward flight, the spacecraft first investigates an asteroid. In August 2000, it reaches its destination. As CRAF travels alongside the comet, it fires a penetrator lander equipped with a laboratory of instruments. These instruments will directly sample chemicals that could be relics of an era billions of years old.
Comets must have impacted the Earth with considerable frequency shortly after the planet itself was formed. So the comets were bringing in this rich mixture of organic material which would have been available to give life a sort of head start, the chemical reactions for life, a head start as we proceed down the path towards increasing complexity and ultimately to life itself. So we want to know, what are those compounds?
What are the chemical missing links in Earth's past? While CRAF studies the comet for 3 years, Cassini's search will take it to Saturn. Cassini is an international mission that teams an orbiter spacecraft built by NASA's Jet Propulsion Laboratory and a probe provided by the European Space Agency ESA. Cassini was named for the 17th century astronomer Jean-Dominique Cassini. Here in the Paris Observatory, he discovered 4 of Saturn's moons and the division in Saturn's rings. Dr. Danielle Gauthier is the chief scientist for the Titan probe.
Cassini was Italian, but Louis XIV invited him to come here, and he discovered 4 satellites of Saturn. Here you can see the notes by Cassini, where he put discoveries.
The spacecraft Cassini will orbit Saturn for at least 3 years, giving scientists an extended look at the ringed planet and its elaborate system of moons. The most tantalizing of those moons is Saturn's largest, Titan. Titan is larger than the planet Mercury and is the only moon with a major atmosphere. In 2002, Cassini will launch its European-built probe to descend to Titan.
The most important, I think, the most important product of the Titan probe will be the measurement of very complex molecules which are expected to be present in the upper atmosphere of Titan, including the organic molecules which are used to build the life. We don't believe that the life exists on Titan because it's so cold, but obviously there is a complex chemistry.
Detailed measurements will be made of the thick nitrogen-methane atmosphere, believed to contain the chemical precursors to a life-supporting environment. Huge lakes of liquid methane and ethane may exist on Titan. The probe will analyze compounds on the surface and relay the information back to the orbiting spacecraft.
Titan has an atmosphere that is denser than our own, consisting primarily of nitrogen, but with a lot of carbon-rich compounds as well. Now, what's fascinating about that atmosphere for us is that it allows us to do a kind of cosmic time travel, as if we could go back in time and see what the Earth was like shortly after it formed, because Titan, being at such a low temperature, has preserved those original conditions. So the kinds of chemical reactions taking place in Titan's atmosphere today, we think, resemble the kinds of things that happened on the very early Earth, which ultimately led to the formation of life here.
Kraft and Cassini are a new series of spacecraft being designed at the Jet Propulsion Laboratory to explore the outer solar system. The spacecraft, to be launched on expendable rockets, streamline design and operations to save costs.
What we're trying to do with these 2 spacecraft is to gain information about 2 of the biggest questions that people have ever asked themselves. One is, where did the solar system come from? The second is, where did we come from? How did life on Earth begin?
Time has obliterated remnants of the past, the celestial past, on our planet. By exploring comets, asteroids, Saturn and its moons, we are looking backwards in time, the astronomical equivalent of being the first to open an ancient vault. It is an inquiry that may lead us back to our distant beginnings.